Perfect, so welcome to the main act of this conference. I hope the previous bands have already sparked joy. This is going to be the talk you've all been waiting for, why your next application should be written with XSLT. I really wanted to talk about this topic for a long time. What are you looking at? What, is the wrong talk? Is not that one? No? Oh crap. I try sneaking in this talk at a conference, but everyone is kind of like, what's he doing? Okay. So let's just quickly get the right one. So what was I asked to present here? I forgot. I'm sorry. Is it the ant talk? No? Which one is it? I think the API one. Is it that one? Okay. Okay. Well, XSLT next time. 10 reasons why we love some APIs and why we hate some others. Right? Okay. I tried to sneak in some of these jokes. So we had a serious talk about fun. I tried to make fun talks about serious things. I try these things. I rehearse these jokes with my wife, and I kind of fail. My wife, here's live footage of my wife when I try her one of these jokes. You know, I don't know why she doesn't get them. Maybe it's me, maybe it's her. She's more into arts. You know, she's an arts consultant, so I tried an arts joke on her. But still, same reaction. Oh my god, what's the... Anyway, so let's talk about APIs. When we work with APIs, this is how we feel, right? We should feel great. We should feel that fun. It should spark joy. So we had this wonderful API from the very beginning of Java. We could interact with the file system, just instantiate a new file like a local directory, and then list all the contents of the file. Wonderful, right? So that feels great. We can iterate over it. Wonderful. So we can use that with any directory, and we see there's a mistake here. So in Windows, I don't have a TMP folder. It's usually called temp. So there should be an exception. What is the exception? The most meaningful exception that we should get here? Yes, a null pointer exception. Where the hell does this give me a null pointer exception? The directory is instantiated. It cannot be null. It's not from inside the list call. It's because list returns a null array if it's not a directory. If I can't find... I mean, they have to tell me somehow that this was not a directory and can't list stuff, but this is just a stupid idea to return null, right? So we all have if it's null, and then we iterate only for this API. This was the old JDK, so we think they've all gotten it better now. So we have new code. It was written by more experienced people. It wasn't just an experiment for set-top boxes. So we have these really nice APIs here, like the stream API, which we all love. So we stream 1, 2, 3. We skip one value, and then we print them. So now in JDK9, I think they've had a new API, right? So other languages don't only have skip where you can pass a constant value, you can also pass a predicate to some new method. They called it skip until, I think, right? So it's kind of like until I reach this predicate, I skip values. That's kind of nice. It's actually not called skip until. Yeah, sometimes it's until, sometimes it's while. So Java is more a while language, right? So in Pascal we had until, repeat until, here we have while, so it must be skip while, right? Because it was called skip before, so we have, no, that's not it, this doesn't compile. It's drop while, drop. Why? Why is it called drop? Because those Scala folks, they have take and drop, and the Haskell folks also have take and drop, but yeah, Java used to use skip and limit. Fine, I'm an Informix guy, used to very old time. I had Informix SQL, and they called it skip and limit. Fine, it doesn't matter what you call them, but why is there a new name for the same thing that does something just slightly different? So that's another terrible idea, inconsistent naming. This is what I'm going to talk about today, these kind of things. Here's an API I love, right? So if it was just me, I would just rant about every API, but I have to provide you with some good examples as well. So here's, everyone knows this, I like it, I really like it. I like jQuery, it's very consistent, it makes a lot of sense. I have all these elements and operations where I can operate on a set of DOM elements, so it's always this mindset, I'm always operating on a set of DOM elements. I've just heard the other talk about functional programming, so this is a very functional approach where I can filter and I still have a set. It kind of feels like the stream API, but it also embeds very nicely with CSS selector, etc. So this is how I feel about the jQuery API. No kidding, I really like this API. So what is the difference? I mean, this is my taste. Maybe jQuery in the front-end world is already dinosaur technology. That's not part of this talk. I want to talk about why does this feel great? Why does this feel great and the file API doesn't? Or in that particular case at least. And I could make this talk not only about APIs, but about languages as well. Like there's this language, everyone knows it. You know, where do you know it from? From Twitter. Just say something, oh, this sucks in Java, and you get these tweets, endless tweets. Everyone says, oh, just use Kotlin. Just use, you know, Kotlin does these things right. I think. I've never actually used it because I maintain a Java API. So let's stop this language stuff, just talk about APIs today. But a lot of stuff appears as well to languages just like APIs. What I want to talk about today is APIs are a crucial part of the user experience. What I call user experience, there's a whole industry that discusses user experience and it doesn't actually talk about developers, but I think it applies to developers just the same. User experience, according to, this is not about user experience, I have another slide here. So why do I talk about user experience? Here's a quote from the famous SICP book, Abelson Sussman. Programs must be written for people to read and only incidentally for machines to execute. So that's why I want to talk about user experience. In a perfect world, this would not be the case, right? So Simone, we had this kind of talk yesterday, but we're actually designing stuff for people. So instead of programs, we can also say APIs must be written for people to read and only incidentally for machines to execute. And that's even more true because the programs, in the end, they must also perform. We must optimize them sometimes. So the code, it might be that the code will never be touched again. That might be the case, but an API, the main purpose of an API is for humans to actually use it. It's not for the machines. We don't build APIs for the machines. Machines don't need APIs. Machines can just run this code and that code sequentially. It doesn't care about why they interact. But we build APIs for people. So there's a certain amount of user experience that should go into it. User experience, here's the Wikipedia definition, refers to persons, emotions, attitudes, about using a particular product, system, or service. And usually this is discussing like websites, SaaS products, and that's a whole industry. How do you design software for non-developers, for everyone, right? For your dad and your mother, etc. And believe it or not, we can replace this word there and put developers, and it's still true, right? We developers do have emotions, right? We do have emotions, or mostly attitudes. We have attitudes. And don't let them tell you otherwise, it's true. We do have that. It's a myth. In fact, I actually have an anecdote here. In fact, I should tell you an anecdote about developer attitudes, like Kotlin. There was this Kotlin programmer, an IntelliJ user, and a Mac user. And they went to the bar, right? Attitude joke. How do I know? Well, after 1 minute, the whole bar knew, okay? Yeah. So we have emotions and attitudes. We connect these emotions. There's absolutely no objective reason to prefer one of these products over the alternatives. That's our emotions that drive them because they who create these products, they actually care about user experience and the marketing, etc., and how we feel about the product. User experience encompasses all aspects of the end user's interaction with the company, its services, and its products. That's a definition by NN Group. So if you ever talk about user experience with someone whose main business is user experience, they will always refer you to this company, NN Group. And also here we can say, we can talk about the programmer as well. Because the programmer is our customer when we sell an API. And we could even, I mean, I sell an API for a business, but you can maybe sell an API to your internal team. So maybe you're in the infrastructure team, and you offer an API to your database or to your fulfillment module to the other teams. So it's always someone else, an external or internal customer, who interacts with your system. So I like this definition also from NN Group about usability, which is closely connected to user experience. So usability is defined by 5 quality components. Learnability is one important component. How easy is it to learn an API when we've never seen it before? And then how efficient are we when we use the API once we've learned it? These are 2 different things, right? So your first exposure to the API should never be overwhelming. That's an entirely different focus. You should be able to discover how it works. And once you've done that, you should be super efficient using it for days and days and months. And then maybe you go to a different project and you come back to this project and you should still remember how it worked. You shouldn't have to go back to step 1 and learn it again. You should still kind of feel, oh, that's how it worked. I remember this, right? And then errors is also something that this website mentions here in this list. I mean, when we make an error, and we all do, is it because we're too dumb, or is it because the API encourages us making errors. Like this file API, this null pointer exception happens to senior developers still today, because that's just something we don't foresee. It's just something we have to kind of remember all the time. So errors, how can we avoid errors just by using the API correctly? And does the API make it easy for us to avoid these errors? And if they cannot be avoided, of course, are they self-documenting? Can we actually recover from the error easily? And ultimately, back to the keynote from today, satisfaction is also very important to usability. We should feel good about ourselves when we use some product. In this case, I'm going to focus on APIs, but it doesn't matter if it's APIs or anything else that you're using. Do we feel good about ourselves? Because that's how we define our success when using this product. So an important observation first before we go on, in this list, there's not a single technical detail, right? So these are global concepts for any kinds of product. I mean, we spend so much time bike shedding this topic here, right? Null was this billion-dollar mistake. And that's not an interesting discussion. Yes, the null pointer has caused a lot of errors because it's kind of hidden, but we still need the concept of null somewhere. We need the concept, so it's not the null concept that we're criticizing, maybe it's implementation. But there are so many bike shedding talks about this, so this is an interesting talk by Stuart Marks, and he also says it's the mother of all bike sheds. Because now that we have optional, we have the same discussions again on a different level. When should you return optional and when not? It's just an incredibly boring discussion per se because it's very low level and technical. We need null in some way, and null is bad when it is unexpected. In terms of this talk, it will become obvious when null is a bad thing and when it's an acceptable thing. So you somehow need a special absent value in some cases where you want to encode that value. There are other prejudices. Our industry is full of prejudices. Sometimes it's just marketing, like this one. This used to be the MongoDB CEO 5 years ago. He said the reign of the relational database is over, so that was 5 years ago. You judge if he was right? I don't think so. Bruno is a fun guy, originally from Oracle, now at Microsoft. He likes to bike shed endlessly about YAML. So he hates YAML, obviously. He likes XML, just like me. And this gets you clicks, but it doesn't solve problems ultimately, right? So all of these things, I don't want to downplay them. They have a history. They're hated or loved for good reasons. But a lot of times, it's hated or loved for technical reasons. I don't want to do cargo culting today. The only time when I actually do this bike shedding, I like to troll some of my friends on Twitter. Like, for instance, here, Nikolai, really follow him, he's a great guy. I'm just tweeting something like this. I actually use these techniques. I use the Boolean type, the capital letter Boolean type for the 3-valued Boolean in Java. Why not? True, false, and null. And it always triggers him. He just has to correct me. I love that. That keeps him busy. I once did a tweet about this. I don't know if you knew that you can do this in Java. You can actually break out of an if statement. Why not? Very procedural way of programming. So sometimes I like the procedural approach much more than object orientation or functional programming. And here it is again, Nikolai, trying to convince me that there are alternatives. So follow him for great Java content and bike shedding. But now I don't want to bike shed. I want to talk to you about the 10 reasons why we love some APIs and why we hate some others. These are my definitions, so before I did this talk, I didn't research this topic a lot, what others have written. I wanted to have this list first, and I actually realized that a lot of others write about the exact same things. So this is not something miraculous, it's just something we forget very often. Naming, simplicity, doing one thing, types, discoverability, error handling, consistency, convenience, compatibility, and documentation. And don't worry, if you can't remember it, there's a handy acronym, just the short way is NSDEC, okay? Just remember the D is silent. Don't pronounce the D. NSDEC. And actually, I delivered this talk at Vox Zurich, and at Speaker's Dinner Vox Zurich, I met my friend Gerald Mücke, and he actually added an 11th bullet. Why do we hate some APIs? Because other humans made it. Funny guy, right? Follow Gerald. Anyway, naming is the first thing. Naming is really important, and there's a mandatory obligatory joke I have to quote here. Probably not by Leon. You can search Twitter for this joke and you'll find dozens of people who get clicks for this joke. There's another joke, I like this one as well. Yes, I know. Naming is actually really simple. And simplicity is hard, right? We have to find simple names. And simplicity is not the same as doing something easy. We have to achieve simplicity, and that's hard. For instance, all of us have felt like this before, right? And here I'm talking about local variables. Now imagine you have to find a name for an API method. Because the local variable, who cares? You can change it, right? Someone will change it anyway because they think my X, Y, Z is not good enough, or I like single arrow names. And someone will change them. But in the API, it's really difficult. So here's a book I didn't read. But you should. The Ubiquitous Language. A language structured around the domain model and used by all team members to connect all activities of the team with the software. So here, it's not just about the names for the API, it's about the names of the business and how to talk to your customers, to your stakeholders, etc. So this is a much bigger concept, but it also talks about the name. Because a name is our common understanding of what something does, and an API is super important. Here's a non-programming API. I know here in Italy it's probably not well known. This is a British company called Ranty, and it's wood stain, and their marketing slogan does exactly what it says on the tin. So it is a wood stain product. You use it to stain your wood, period, right? So the name, that's their asset. They have many products, and it's always just, it's not a fancy product name, something hypothetical like, I don't know, Quarkus we've heard today. What is Quarkus? It doesn't, the name doesn't say, I mean, I don't agree necessarily, but the name doesn't say what it does. Here, they say the name of the product is exactly what it does. That's a nice marketing slogan. For instance, back to stream. This is not how we do it. So we used to have skip and limit, fine. There were those discussions when they developed Java 8 and the stream API. A lot of people said, don't do skip and limit, use drop and take, because that's what all the cool kids do. And they did eventually, right? But they didn't refactor the old names because it's the JDK. You can't change names anymore in the JDK. They should not have introduced the new names. It's now, this concept skip is well understood. So it could have been just called skip while. You know how this happens, right? Every single time. Why does this happen? This is one person implemented this supremely nice API, and someone else touched it, yeah? And it was not peer reviewed. That's how it happens. The language has changed, and usually it can be fixed. So if it's your internal API, you can fix this very easily, but you always have to keep backwards compatibility in mind, and sometimes that's just supremely difficult. So if you have customers that use your API, you can almost never change the names anymore, because a breaking change just because of a name change is kind of difficult to argue. When a customer sees that, all my code breaks because you just tried to rename skip to limit, skip to drop. No one will understand that. So for new API, it works, but you have still this discrepancy between the two names. So sometimes this is more important than good, consistent names. And that's also one of the caveats of this talk. It's all about trade-offs. Here's a quote by Roman Elizarov, the Kotlin product manager. Follow him as well. He has a lot of interesting, good tweets, very deep technical thoughts. Trade-offs are constant and inevitable. We trade off convenience for performance, trade consistency for compatibility, ease of use for features. It's always a trade-off. And this is why, in terms of API design, we should better get the names right from the beginning, because we cannot change them. And we should talk to each other, of course. So here's another example, monads in Java. There are 3 monads. Like the stream API is a monad. And in the other talk by Uberto before, we learned what it actually is, a monad. But in short, in Java, it's usually map and flat map. As soon as you have these 2 methods, it's more or less a monad. So this looks nice. So we can transform a stream into a stream by having a function that maps the argument of the stream, the content of the stream, and we can have another function that maps this content to new streams, right? So these 2 operations are necessary for a monad. We have this one, we have the optional monad, and the third one is completion stage, which then apply what? Right, so this is not really a very interesting example, so we don't feel monads yet in Java, but in terms of future evolution of this API, it was kind of a mistake to just invent a new name that you can't discover, and you don't easily know what it is when you see it, and they actually added it to the Java doc. I think this edition was only added in Java 9, I think, because Mario Fusco, who runs with his team this show here, had a whole talk about this topic, about monads, and he was ranting so much about this example. Actually, I stole it from him. So maybe because of him, they added this to the Java doc, I don't know. So it can't be fixed. Now, I'll show you a good example. As promised, always a good example. So here's a very good example, a very thoughtful API, which solved a lot of problems very well. So this is Juke, for instance. Just take this example here, a really good API. Very obvious method names, right? So this models the SQL language in Java as a domain-specific language, so every SQL keyword is a Java method. Yet, yes. Even in Juke, almost perfect API, this was called field for ages, right? So in a database you have columns, and for some reason it was called field historically, and then suddenly there's this column name again. What is it now, field or column? It happens to the best. So naming, bad naming in their API, you know, all the time we're ranting, bad naming in our API, yes, okay. But it's really difficult. You have to restrain yourself so often. So for instance, not only is it called field, but it's also called condition in this API. And it would be really much better to call it a predicate. It's kind of the same thing, but predicate is what the SQL specification, the ISO SQL standard calls it a predicate. Most databases call it a predicate. And this API calls it condition, so it would be nice to rename, right? So every day I'm thinking, because my company develops this API, I should do it, but I have to restrain myself because that's one of the examples, it doesn't matter that much. And the impact on all the users is horrible, right? They have condition all over the place, and now suddenly it's called predicate. So changing the API is easy for the one that maintain them, but you have to change the documentation. And if you change the documentation, no one does this. You see those redirects in old documentations? No one does this. Why don't they do this? I don't understand that. It should be part of the documentation, but if you have an old version, it doesn't redirect to the new one. So you have tons of dead links, and you have to think of external documentation as well, like on Stack Overflow. So if you're building a public product that is used by everyone, well, you're not going to update Stack Overflow. And you have tons of dead links, and that just, for what? For a change of name, that's not worth it. You have to write good release notes to make everyone aware, upgrade notes, keep the old name around sometimes for backwards compatibility. It's just not worth it. So again, you should get it right from the beginning. So here's another example that does it right. I really like this API. In the beginning, it took a little bit of time for me to get acquainted with the way it thinks. It works a bit different from all the other JDK APIs, but once you learn it, it's really, really obvious and very efficient. So it fulfills the usability, the list of usability concerns. So now is a very obvious name. What does now mean? It's obvious. In the context of the local date time, I'm getting the now value, right? So that's very obvious. Parse is obvious as well, and we have that name on every type. So every type has a parse method. And it's not even by contract, so these don't implement an interface that has a parse method, they're static methods, but by name, I will rediscover this method because I need it there as well. And we can create a type, a value of its parts. So of is a keyword, and it always means the same thing. We can create the type of its parts. It goes on, at creates a more precise value, so we have the local date, and we want to get a local date time at some more precise instant. It's always at. And get extracts a part, and is runs a check, and minus and plus are obvious as well. And with replaces a part. So you get a new value with only one part replaced from the old one. So I really, in terms of naming, this API is a really good place to learn how to do it. Start of day, so they have different concepts for similar things. So start of day is a concept that is immediately understood. Day of month is something else than the day itself. So it's easy to learn. So it's a complex domain. Date-time arithmetic is complex, but it's really easy to learn in this API. They really made it very well. There's some guidelines. We always knew this. In object orientation, especially in Java, we have adjectives for interfaces, nouns for classes, verbs for methods. So there are tons of guidelines. It doesn't matter which ones you follow, as long as you follow them through in your case, right? So better get it right from the beginning. Simplicity. Second bullet, so I've already run through so much time and I'm only on bullet 2. Luckily, it will get faster. So simplicity, the technical view here. I didn't have time to write a short letter, so I wrote a long one instead by Mark Twain. I like this quote because simplicity takes effort. We can easily write the long letter, but being concise and simple is different. Here's the manager version of this quote. I didn't have time to think about who this is for, so I CC'd everyone instead. Right? We all know this. I Googled simplicity quotes. I found random quotes. Most of them are spiritual in nature. It is pointless to do with more what can be done with fewer, by William of Ockham. I have no clue who this is. Seems like a church guy from the 1400s. But it's a spiritual point of view, or another one, also spiritual. The more you have, the more you are occupied. The less you have, the more free you are. So why the spiritual context? Why? It's not about religion here. It's about the human being, our human nature. We loathe complexity. We hate it. We hate it absolutely. It's not because it's not manageable by the system. It's just we can't manage it in our heads. And it applies to our spiritual well-being, etc., but also to code programming. Maybe in a fun context, but also definitely in an efficiency context. So here's an example of not to be simple. This is a Java compiler class from the Java compiler module. And then we have this method, getTask. If you ever run in-memory compilation in Java, it works very nicely, but how do you actually use this thing? In me, it causes existential angst. It's like, yeah, right, I now have to call this method, and what I'm going to pass to the method, right? So I feel, oh my God, right? You get the point. So I have here 6 parameters. We, in our hearts, know that's a bad thing, 6 parameters, but they still have it, and they're stringly typed. So we have here options that are strings. Yeah, I understand the technical reason for this, right? So because on the command line, you can pass arbitrary strings, and the compiler actually doesn't know it, and you have to pass them to some annotation processors for them to be understood. There's a reason for this to be stringly typed, but when I see this the first time, I'm scared. And if they're not stringly typed, this Java file object here is quite difficult to build. It sounds like something easy. It's a representation of a Java file, but try building it. You have to implement about 7, 8 methods. And you don't know which ones you have to implement because some of them are optional as well. So it's really hard to use this API, even if none of these things are inherently bad, and the implementation works very well. I've written a couple of in-memory Java compilers for customers in the past. Really wonderful how it works, but it's difficult to use the first time. And I had to abstract it for myself so I could reuse it before. We're humans. We can only keep so many things in our heads, right? Complicated APIs are frustrating. So Juke internally does something like that as well. So internally there's an API that does this. In most of the cases, this is sufficient. I need a class name and the content. So this is not going to be as fast and optimizable as the other solution. So if I really have to be fast, I'm going back to the other solution. But if I run an integration test on an annotation processor, I want to write something like this. This isn't news. We've always knew this. So this I've discovered from a talk by Josh Bloch. And Josh Bloch referenced a quote by Wheeler. The prime objective to be borne in mind when constructing subroutine libraries are simplicity of use, correctness of codes, and accuracy of description. All complexities should, if possible, be buried of sight. And he discovered this right after inventing subroutines in 1952. So before, there was no concept, no name to attach to this concept of a subroutine, of reusable code, and immediately understood it must be a simple thing to use, because otherwise there's no point in this subroutine. He didn't implement this for the machine to execute. He implemented it for other programmers, and he was the first programmer that actually built a real-world system, one of the first, of course. But he also invented bike shedding. That's funny. He wrote this 2-page paper, and he embedded bike shedding in the paper. So here it is. How are the subroutines going to be stored? Are they going to be stored on punched paper tape, or are they going to be available in auxiliary? We're always getting distracted by these discussions, which are not essential to the topic. So he also invented bike shedding. He was the taps of the spaces of the 50s. So how to be simple is really difficult, and we are still struggling with this. We will never get it completely right, but when we design an API, we should just spend 5 times the amount of time to make it simple. Some things are obvious, like low coupling. You can read all these books on cohesion coupling, etc. A lot of other things are less obvious. Simplicity is a lot of work. It requires experience and reiterations and redesign of your API, maybe a second major release version. It emerges from careful design. Maybe sometimes simplicity cannot be designed up front. You have to test it. You have to actually use it in tons of iterations. So in the end, I can't tell you how to achieve it. It's kind of like obscenity. I know it when I see it. So this is a quote from I don't have to go into the details of this, but I like the quote itself. It's simplicity, I know it when I see it. I can't tell you how to get there, but when you see it, you know it's simple. The next bullet is do the deal, right? Do one thing and do it well. It's actually abbreviated as this. So here's the one example. You don't read all the details, but Eric Raymond had these 17 Unix rules. Doing one thing was spread across all of these, building modular programs, so a program is modular and can be reused. And Unix is really great in this, right? So you have these tons of little programs You can pipe them together, and everyone does only one thing, and you exactly understand what it does, and you know when to use it as soon as you've learned that it exists. Composition, simple programs, small programs, transparent programs, unnecessary output should be avoided. All of this is about doing one thing and simplicity, so you cannot implement simplicity without doing one thing. And that's the end of the bullet. This one is really, really simple to grasp. We just have to be diligent enough to actually implement it. Types. Now, types is an interesting topic. Type safety is one of those bike sheds, right? We can endlessly discuss type safety. Type safety is not what I want to discuss here. I say great APIs can exist without type safety, but I don't believe they can exist without types. Now, type safety or not is something philosophical, but if you look at jQuery again, it's full of types. The types are in the implementation and they are in the documentation. When you run filter in jQuery, filter takes a function or a selector, and the documentation tells you what the type is. It's just you can't express and type check that with the JavaScript compiler and interpreter. But behind the scenes, there is a type. So in the design, there is a type. And you should design types regardless if you type check them, right? So if you ever code in JavaScript, you will still do that. It's the same discussion with databases. There are no schema-less databases. That doesn't exist. There are only two types of databases. The ones are called schema on read, and the other one's schema on write. Schema on read means you don't care about the schema when you write to it, so you discover it when you read it. NoSQL. And schema on write is it's being validated once you write to it. So it's enforced, but ultimately you have a schema in your programmer mind. You already think about the schema, you design the schema, you just don't type check it necessarily. So types have a few very decisive advantages. They may have a name, they simplify your design, they do one thing, they're types, and type safe in Java, they help you discover the API, etc. So it's actually the same thing as this whole talk. Types enable all of these things. All of what I'm telling today is because we can use types. So in a way, this talk is about types. And now, there's another discussion, more bike shedding. There are some people who prefer nominal types, right? So Spring people used to prefer nominal types like this one. They like this type, this kind of type. So you know immediately what it does, and it implements another type that also is very clear, right? This is how you work with Spring. And they've moved on to more structural typing now. I've read this Spring blog post here, so they actually try out now the different paradigm of structural typing, so now we have something like that, right? So this is from the Reactor HTOS extensions. So everyone thinking what I'm thinking? This is not a good enough type yet, right? We have to go deeper. So maybe this one here is better, right? This is a better type. And make no mistake, that's not a merge conflict there. Yes. So I can't help it. Some people add syntax sugar, others add syntax vinegar. And it's really easy to make fun of others. I like that. Let's introspect a juke type here. A juke type, so this is a juke type. It's actually not a type, it's a method. There's a method here, and that's a type right there that's being returned. So when I develop juke for you, I have these kind of compilation errors with my types, but you don't see them in your, when you use the API. This is all hidden in the implementation, right? So if you zoom in on this, this is really hairy. But what's the point of this kind of type? So structural typing can be very useful, even if it's sometimes a bit hairy. So on this row 22 type, you have a condition method that can take the same type again with the same type variables, and you're thinking, what's the point of that? The point of that is, I can compare a tuple with a subquery in Juke, and if I forget one of the columns, I'm getting a compilation error here because that doesn't type check anymore. So structural typing can help here if you can hide it well enough from the user, so the user should not see these types, and then you have this kind of benefit. So what's my point here? Ultimately, it doesn't matter if you're structurally or nominally typed. Ultimately, types are semantic. They convey a meaning. They self-document. And this works with both nominal and structural typing, with both static and dynamic typing. I made fun of this before, of this example from Spring. The important thing for you is this type here, and you're obviously not surprised by this being useful to you, having an employee type, because you can attach stuff here. The mistake in this API, or it's not a mistake because Spring is actually an infrastructure library, so you're actually at some point needs these infrastructure type. The mistake you might make here is not using only the interesting type, but leaking the infrastructure type into your code. So that's a difficult thing to get right, to have only those types you actually need around, right? So simplicity with types can also be something quite difficult. A counterexample is from the old days of JDBC. So this was how to create a statement with JDBC, and we have these ints that we can pass here, and that's, where are these types, these ints? You would expect that to be on connection or on statement, but actually it's in the result set, right? So you can't easily find out what, is it 1, 2, 3 or what? It would have been better if we designed JDBC today to use an enum, right? So that's an obvious choice for these 3 things. There are actually enums, but back in 1997 we didn't have enums. So these are the kind of things we should think about, right? So stringly typed stuff or int typed stuff is obviously bad, but sometimes we're using it. At some point it's inevitable. So here we have sax parser and we want to be able to pass arbitrary flags to the implementation. But there are only few implementations that are actually existing, so maybe it could have been done better in this example as well. So we have more types to pass as a configuration or property, right? So it seems kind of obvious to use types, but sometimes we just don't do it for laziness or whatever. And you know what else is stringly typed? There's another example here. This is stringly typed. Think about it. We can actually introspect these annotations. I've just seen Gavin King build a new tool that introspects JPQL from your annotations in the compilation phase. It's interesting, but maybe we could have used types from the beginning instead. I don't know. So that's that with the types. Bullet number 5, discoverability. And this is one of the most important things in my opinion. Discoverability. When you go to Stack Overflow to discover how to implement your logic, I found a very interesting question here. How do you define a good or bad API? And because it's such a good question, obviously it was closed. Yeah? But the not accepted answer here was, that I really liked, is you don't have to read the documentation to use it correctly. The sign of an awesome API, right? You don't have to. There is documentation, obviously, for the really complicated stuff and the detailed stuff, but I don't have to read it as the first thing to know how to use the API. Here's a good example again. So the stream API is really good for that. I have a stream of 1 to 3, and I autocomplete, and I have my choices here, and I can discover the choices with my IDE, or with the Java doc, or with whatever tool I'm using, right? I can discover the optional, I don't even have to know that this was now an optional type that is returned from find any. I can just start discovering, what can I do with this thing, right? So to learn the API, this is essential. To get it fast and right, it's not the most important thing, but it's essential to learn it. Here's another obviously great API, this one, right? The same idea, you have this entry point, there's a single entry point, and I know I want to write a select statement. I could have written another one, but here I'm writing a select statement. So this is really something at the core of this API. We know it's a SQL language, and we can pass columns to the select statement, to the select clause, and we can autocomplete everything. We can discover our schema as well, not just the SQL syntax. And then obviously there must be a from clause here, and what options do I have, et cetera, et cetera. So some people like reading docs, others like navigating the API. Both are reasonable things. This is a personal choice at some times as well, not just an obviously better way to do it, but your API should accommodate both. That's my opinion. And to achieve that, your API should have a small set of entry points. So here was a discussion with Christian Humer from the Graal team in Zurich. Especially DSLs like Stream or Juke or something like that should have almost only one entry point, because that's how you guarantee that it's discoverable. Spring doesn't work like that, for example. You have tons of types, and you can discover them by starting in your IDE, searching for class names. So when I search for a data source something, maybe the name has data source in it, but it's in some package, in some module, in some library. It's really difficult to discover stuff. The entity manager from JPA is good, for example, in this. When you want to work with JPA, you know I'm going to start with the entity manager. I have that somewhere. Someone configured it for me, but now that I have it, I can start from there always. I will always start from there. I will discover from there. And it doesn't have as much as Juke, for instance, in terms of API surface, but it's very easy to discover stuff from there. Now, no one noticed here, I have a bug like this here, n+1, right? So that's the downside of this API. It makes it easy to discover, but it's sometimes easy to discover means you're fast in completing it and you don't think about what you're doing. So that's not a mistake from JPA here. The problem is that you actually shouldn't have a size method on all your nested collections. It's just a historic thing that we have with the Java collections. But now I'm interested in this. I wanted to write a quick test case where I have an entity manager and I already had a data source. So in my naive point of view, I have this data source, and I think they're the same thing. A data source and an entity manager are kind of the same thing. It's just an enhanced data source with caching and transactions, etc. So I would want to have some tool that wraps me this data source in an entity manager. What I got when I tried this, and I have no idea if I did it right, I got this code here. I used Spring because I found most tutorials about Spring on Google. Maybe it was possible with JPA directly or with Hibernate, but I used Spring now because I got that one to work. And I don't feel good about myself when I write this code. So it's for an integration test, so it's kind of okay, right? So this is kind of throwaway code, but let's look at it in detail. I just picked this one as random. I found Entity Manager in the Spring API. I searched for asterisk, Entity Manager, asterisk. I found these things here, and now which one is the right one? I picked one, and it worked. Is it the right one? I don't know. I could read the docs, of course. And I had to say Hibernate 3 times. 3 times Hibernate. I mean, this thing is built to, I mean, what else is there? Yes, Eclipse link, hardly anyone uses it anymore. It should just work with Hibernate, right? I had to say it 3 times, and what is this? Why did I have to do it? I have no idea anymore. I could have commented this, or maybe it's no longer needed. Maybe Spring has evolved, and they now know when the properties are set. And why is it called getObject when it only returns an entity manager? I have no idea what I'm doing. So this is not a discoverable API. I've discovered blog posts, but not the API, and now I have no idea what I'm doing. This is why I don't feel good about myself when I use this. This is personal. Maybe you have tons of Spring experience, and you don't fall into these traps anymore. But for me, when I learned this, I don't think this is well done here. I don't have confidence that I'm doing it right, and I'm sure Ollie will hate me for this, but what did he say when I said something like that on Twitter? Ollie is from Spring Data. Yes, right? I should know what I'm doing. Yeah, how do I know what I'm doing? I have to read the manual of every version, and then the next upgrade is different. I don't know what I'm doing, and I don't feel bad about it. That's how I am. I'm a user, and we've already had this discussion. I really love talking with Simone about these things. We had this discussion again about Hibernate in the past. I'm this user. I want it to work. I don't want to discover, when I discover it the first time, why it doesn't work. Docs are great, discoverability is better. Having both is the best. Good examples in the JDK, Java 8 Stream API. JPA is great once you have an entity manager. It's really easy to see what's possible. Obviously, Chook, yes, it's a great API. jQuery, I like Java Time. I already noticed it in terms of discoverability. There's not a single entry point, but you always know it's just one package and you know which type to choose because they're very well named. So here naming is the key to discoverability. I like Wistel, not SOAP, but Wistel. It's a single file that documents your entire API. You can see all the types in one document and you can annotate them with documentation. It's just a bit more verbose, but the idea was great, and we can also use proprietary technology for the new stuff, right? Okay, so let's just appreciate one moment how great this one is. Okay. Bullet number 6, error handling, right? Bullet number 7, consistency. Yeah, I'm just kidding. Error handling is really difficult. So here's my PL SQL attempt, error handling. This doesn't compile, obviously, because this, right? Why doesn't it compile? So end is wrong. What should I do now? How about this instead? Yes, a block must not be empty. I forget this occasionally, not anymore, but in the past I used to forget this because other databases support empty blocks. Ah, yeah, now with this error I would have understood what my mistake is. I put a null statement here or whatever. So error handling, it's not that hard to understand what is important. Also in Eric's 17 Unix rules, error handling is all over the place. We can bike shed about error handling as well if you want. The bike shed here. This used to be error handling. I think everyone agrees we don't do this anymore with stringly typed error messages like the int that is used to be returned from C. That is not very robust error handling. It was better with exceptions. Now, no one likes exceptions anymore, but in principle, they were kind of a good idea. They were used as checked exceptions in the wrong places, but if you have checked exceptions in business logic, yeah, but we can do it like this now, so the cool kids do it like this, right? We can flat map our errors, and we feel smart about ourselves. This is mostly irrelevant. All of this stuff is irrelevant. You should just be consistent and return meaningful errors. The most important thing is that the caller knows their mistake and they know what to do about it. And you choose one of these technologies, I don't care. Types, exceptions, try-modded, either-modded, etc. It's better than strings and ints, and that's it for me. You can continue bike shedding during lunch. So consistency. Consistency, the next thing here. Let's skip this quote. I'm running out of time. Consistency is at the core of these two things. When it's consistent, we're going to be efficient. We don't have to revert every time to start learning the API from scratch because it's someone else wrote it and they have a different opinion about things. So it makes us efficient, and when we get back, we remember, oh, that's how it works, the API. It worked like this. They love checked exceptions, fine, okay, I'm using this API, but everything is always a checked exception. And here's an average enterprise bean, which is inconsistent. Not only, I wanted to simplify it, but the original example was actually like this, so we added these annotations here, right? Average enterprise being like in your code, probably? Yeah, who's seen my talks before knows this joke. It's always, I recycle this every time. But when we have an inconsistent API, we feel, it's always, why? And this stops our world. We discover it, and then it's like a breakpoint that we forgot to take out from the debugger. And we have to think about it, even if it's obvious what it does. In this example, sometimes we return a list, sometimes an array, sometimes a stream. It's always the same thing. It's a collection of something with different properties. But it's always the same thing conceptually. Just stick with one of them. Or optional, or null, or exception. In the old days, we used to throw exceptions when we didn't find something. That was the J2E way of saying didn't find anything. Fine, if that's how you work, then do it this way. But always do it this way. Don't suddenly return null and don't throw in exceptions. All fine, choices are fine in terms of API design. Just pick one. There are subtle ways to be inconsistent, which I'm just going to skip. The Liskov substitution principle. JDK is full of examples of inconsistencies. I'm skipping this. We have no time for this. Other ways to be inconsistent, if you ever work with a different language like PHP here. Sometimes you search the needle in a haystack, sometimes in the haystack you search the needle and it's not strongly typed, so you're pretty much screwed, right? You always have to read the docs, unless you use this every day. I feel like this. Actually, the Juke website is in PHP. Yeah. Anyway, I'm skipping because the time doesn't, this is actually a 1 hour talk. Why consistency? Consistency is the core of usability, and all of these are affected, right? So it's kind of obvious. Convenience. So Brian Getz is also like me. He likes to blame others and never takes blame himself. I like that attitude. So he says, key API design questions to ask yourself, what abstractions am I asking the users to understand before they can use this API? Do those abstractions serve the user or just the API? Like he probably had something to do with JMS and then he ranted. And in JMS, indeed, you have to instantiate maybe 5 objects before you can send that message. Wouldn't it be better to be able to send it just with 1 object? And you all built this utility stuff. Convenience is really cool. We've done this forever. We've done this forever, and then we pull in a library that does it for us. But everyone has to Google it. No one remembers this. Right? We've done this forever. It's boring and the manager doesn't get the results. 9 major releases later in Java, we finally have this on input stream. Right? This is convenience. It was not necessary, but it's convenience, and we feel great about that because now we don't have to remember the stupid logic anymore. Convenience is the most underrated API feature and language feature. How to achieve convenience? By dogfooding. In my opinion, this is the best way to achieve convenience because yeah, this is an English term, dog fooding. I find it kind of funny. You eat your own dog food, right? You're a dog food vendor, you eat your own dog food. You use the API all the time. So this is me when I use my own API. And I feel like that. What the hell was I thinking here, right? And I get angry at myself and I improve the thing. Actually, to be fair, this is me when I use any API. Yes? Okay. But at least my own API can fix it. So dog fooding means I get better objective quality, right? I can test stuff. I'll skip these as well. You already know that. It's great. And better subjective quality. Like, for instance, this example here. I did this all the time. All the time I ran with Juke in the integration test. I called fetch all the time. And this got on my nerves. And I realized maybe I could just do it like this and not call fetch anymore because this here could be a iterable. And then calling iterator on it executes the query. And now I have the same feeling like in PL SQL. It's not a huge change, it's just one method less, but I never have to call it again. So convenience is really great. Other languages have very cool features that make your API convenient, so Kotlin is one more of these examples. It helps API designers make even more convenient APIs. It's not a game changer. It doesn't solve the big problems, but makes people happy. And happy people will recommend your API. And now I definitely have to skip these things. Compatibility, just to summarize, don't do this, right? Anyone ever worked with Python? I don't know what they were thinking. I mean, there are probably more subtle examples, but why would you do that? Or why would you do this? Why? Why? Don't do this. All code breaks. You can never upgrade to Python 3 when you have Python 2. Little is gained. On the other hand, the JDK, sometimes. Yes? Okay. But you have to be pragmatic. Read the books. There are great books about this. Read the Eclipse is nice. They have these. They have a lot of thought put into backwards compatibility. They even have compatible URLs. So who has ever worked with Eclipse? They achieve compatibility by just adding a number to the type, and then you have to implement 5 of these types that are the same thing. But you can only implement 4, and then you're still compatible. And finally, documentation. This is how it works. Right? We didn't write that yet. This is like testing. You know where testing goes? It goes here in the waterfall. We do it at the end, perhaps. And that's where we do documentation. So here we have code. We document our code. Why do we document our code? Some architect comes, says, document your code. So we add the documentation, which is super important. I'm joking, of course, but it's the dual of discoverability. Discoverability means I don't know what I need. API, what do you have to offer? And documentation is, I need this thing. API, do you happen to support it? You need both, right? You need documentation, but it's for a different use case. I have this, I want to quote this website by Devio, a Swiss company that has 4 different types of documentations listed here on their website, really good ideas. So the top ones are for new users, the bottom ones are for seasoned users, and the vertical line is for different use cases. So you have to think about these things when you write an API. There are different types of documentation for a different audience, and we've reached the end of NSDEC. NSDEC, remember the D is silent. Design for humans. This is important. Design for humans, not just for your implementation. And remember, programmers are humans too. Now, if you don't believe that, for some reason, there's a proof. Just try this once with your coworkers. And you can feel their emotions coming up, right? Okay, great. Usability, review the slide. I really like this definition of usability. Learnability, efficiency, memorability, errors, and satisfaction. Now, a little bit more consumer information. I just wanted to make sure this message is received about APIs. This was this really good API here. Do check it out. It makes you feel great. Very usable, very nice, excellent. Are we done yet? Stopping it? Okay. Thank you very much for your attention. I hope you liked it. Enjoy the rest of the show.